Don't be ashamed of needing help. You have a duty to fulfill just like a soldier on the wall of battle. So, what if you're injured and can't climb up with another soldier's help? Marcus Aurelius. Today we're covering cross-country flight and nav systems. Here's the battle plan. As usual, we'll start with a scenario. You'll have the opportunity to share what you've learned about aviation jobs. We'll cover cross-country, get into nav systems, and do a quiz and assign some homework. Here's our scenario. Watch it and tell me what you think you should do. So obviously we're on final here. We got 3 reds, 1 white. What does that tell us about our glide slope? Where we are in relation to the glide slope? There we go. Now 2 reds, 2 whites. How's our airspeed looking? Rate of descent. Now we've got 3 whites and 1 red. All right, talk me through the procedure. What do you do? So we've had a bird strike that led us into an engine fire. So one of the things we want to do is starve that fire. So we pulled the mix, killed the master, and at this point, since we're so close to the runway, we might as well just glide it in. Something your checklist might have you do is pitch for your emergency rate of descent, or emergency descent airspeed to try to extinguish the flames. But in this case, yeah, we're just going to try to glide it in. This is what I think is so great about having a home simulator. You can put yourself into situations that you couldn't safely do in real airplanes. So you and your instructor can, spawn spawn birds on short final and have you deal with an engine fire right before landing. Or you can, fly into IMC and practice getting yourself out of it. So I think it's a good idea to pick up a home simulator. Basically, it's the cost of like 1 flight, maybe 2 flights, and then you got countless hours that you can practice at home. All right, take a minute now and talk about your research on aviation jobs. There are more jobs than just being an airline pilot, I promise. So take a look at it and then report back. And let's move on. Let's talk about cross-country flight planning. First of all, you are the pilot in command, which means you are responsible for determining if the aircraft is safe for flight. That is, using your Northwest craft checklist. That's NOTAMs, weather, known delays, runways, alternates, fuel, and takeoff and landing distance calculations. That also includes the I'm Safe checklist, and that stands for illness, medication, stress, alcohol, fatigue, and eating. This is to verify that you, as the PIC, are safe for flight. Basically, you are responsible for making sure that every little bit of the flight is going to go safely. Part of that is also doing our pre-flight inspection, and we're going to do that using a checklist. That's a systematic means recommended by the manufacturer. And remember that the owner or operator is responsible for maintaining the airplane in an airworthy condition. That is like if you work for Alaska Airlines, they are the owner or operator. You are the pilot in command. So that's the difference between owner-operator and PIC. Let's talk about taxiing. Whenever we are taxiing, we also have to deal with the wind. Remember that the airplane is an aerodynamic vehicle. It flies based on wind, essentially. So if we have wind strong enough, it can actually get underneath the wing and flip the airplane over. So whenever we're taxiing, we want to account for any crosswind or any wind hitting our wings. So here, if the wind is coming from our left side, a quartering headwind is what it's called, we use up ailerons. We put this aileron up to help force this wing stay pegged to the ground. And we also use neutral elevator, so we don't pull up or push down on the elevators. On the right side, we do the opposite. This aileron comes up, and then a quartering tailwind, we're going to put the opposite input in. We're going to put in a down aileron here to stop the wind from getting underneath the wing, and again, pegging that wing to the ground. And then if we've got a quartering tailwind from the right, then this aileron goes down. And we also do down elevator if we've got a quartering tailwind. So in general, if you've got a quartering tailwind, you're going to fly away from the wind. If you're getting a quartering headwind, we're going to turn into the wind. Let's review. Who's responsible for determining that the aircraft is safe for flight? That's you, the PIC. Who is responsible for maintaining the airplane in an airworthy condition? That's the owner or operator, Alaska Airlines or your flight school. Now talk me through how you would hold your controls if you've got a quartering headwind from the left. Now you're gonna hold this aileron up to try to peg that wing down to the ground and not let air get underneath it. How about a quartering headwind from the right? Same thing. This aileron goes up, and of course neutral elevator. And a quartering tailwind. That's right, we're going to have the aileron down on the side that the wind is coming from. So down aileron here, and a quartering tailwind from the right, down aileron here, and down elevator. Let's talk about our airspeeds. If we encounter airspeed, we're going to reduce our speed to maneuver speed, and we want to maintain level flight attitude. Basically, if we have a bunch of turbulence and we try to maintain a cruising airspeed, maintaining altitude, and forcing the aircraft to stay where we want it, we might bend the plane. So holding a constant altitude, constant airspeed is usually impossible and may lead to additional control pressures that put stress on the aircraft. So remember, if you get into turbulent conditions, maneuver speed is the best way to go, and just try to basically hold a level attitude, not an altitude. If you have a power failure, if your engine dies, we're going to pitch for our glide speed, and that's a speed that you should have memorized at this point. So kind of like remembering our ABCs, we pitch for our best glide speed. That's airspeed. B is the best place to land, and C is a checklist. So right now, tell me what your aircraft's glide speed is. Go. I'm sure you got it. And you don't want to try to maintain altitude if you lose your engine. You're just going to stall and possibly spin in. So you lose an engine, ABC, airspeed, best place to land, checklist. Your max gliding distance is obtained when your total drag is minimized, and that is at that aircraft's VG, or our best glide speed. If we try to stretch our glide by either pitching down and increasing airspeed, or pitching up and losing airspeed, we're going to actually fall short. So if this is your airplane, look at my beautifully drawn airplane. If you are pitching for VG, your best glide speed, you're going to glide down and hit a point. If you try to stretch it by nosing up, you're eventually going to fall short. And if you try to pitch down to try to increase your glide, you're actually going to fall short again. So your VG, or your best glide speed, is the best, of course, by definition, the best glide speed. So if you lose an engine, glide speed. And this is what this is. Variations in glide speed will nullify ability to accurately determine gliding distance and choosing a landing spot. So what should you maintain when you encounter turbulence? That's maintain level flight attitude. And your max gliding distance is obtained when total drag is minimized. Let's move on to navigation systems. Let's start with the VOR. That's the Very High Frequency Omnidirectional Range. This is essentially a short-range radio navigation system. If we go look at our chart sectional, there are these little VOR stations that send out a signal in all directions. That's the omnidirectional part of it. And what we do is we can actually use these signals to identify waypoints or navigate to different airports. You might be asked to identify your position using the intersection of two VORs. So let's pretend that's another VOR. And this, we're receiving indications from both of these. They'll ask you, where are you? And you can figure out by using resection. Remember that radials are from the VOR or leaving the station. So anytime somebody says, you are on the 090 radial, that's moving away from the station. And I have a video dedicated to VORs. I'll post it as well. If you are flying in instrument conditions or IFR, you need to test your VOR every 30 days. And so we use VOR testing facilities, and they're available on specific frequencies at certain airports. This can help you check the accuracy of your VOR on the ground. You can also test your VORs in the air, if you follow the chart supplement. Basically, it's limited to areas and altitudes specified in the chart supplement. They're also going to give you all the frequencies, identifiers, distances, and descriptions in that chart supplement. So let's talk about how you test your VOR. So first of all, you're going to tune the VOR radio to the specific frequency that we're going to use to test it. And then we're going to center our course deviation indicator. The OBS, that needle, should read 0 or 180 regardless of your position at the airport, and it should say 0 degrees from 182. That's saying, if we pretend we're actually using the VOR for navigation, we need to fly a heading of 360 or 0 degrees from or away from the station, and 1802. 1802. So it should indicate essentially that we are to the north of the station. So 1802, 0 from. The accuracy of your VOR needs to be plus or minus 4 degrees on the ground and plus or minus 6 for airborne checks. Oh, you should, don't look at these, don't look at these. What is the required range of accuracy for your VOR? And I'm sure you got it, plus or minus 4, plus or minus 6 for airborne checks. All right, so let's practice. We have tuned to the Ephrata VOR using 112.6. First of all, let's identify it. That's the Ephrata VOR 112.6, and the station is right here. And we have an indication of 210 from. Remember, that's a radial, saying that if we were to fly directly away from the station, we'd be on the 210 radial. So looking at this ring here, that's that blue ring, 210 is right here. So we are somewhere on this line from the station. Now we tune our second radio to 240 from Moses Lake VOR. So let's identify that. Moses Lake 115.0, that's this VOR. And it's actually right here. And we are on the 240, so that's 239, somewhere about right here. So we'll draw a line about there. And so now we can see if we are on the 210 from Ephrata and the 240 radio from Moses Lake, we know we have to be right here on this part of the chart. Let's see if I'm right. Yeah, there it is. Boom. Got it. Let's try again. I'll give you a second to try it for yourself. So the tune to the Ephrata VOR. First identify it. Let me know when you've got it. Right here, Ephrata 112.6. And then 253 from Moses Lake. So where's the second VOR? It's over here. 115.0. And it's the 220 from Ephrata. So there's Ephrata, there's Moses Lake. 220, there's 2122. Something like this. And the 253 from Moses Lake. Now that's actually super easy right here. And so we would be somewhere on over here-ish. Let's see. Yeah, close enough. All right, let's try again. 227 from Penco VOR and 267 from Payne VOR. First, let's identify the station. Penn Cove, that's it right there. 117.2 Penn Cove. And we're on the 227 radial. That's 18, 19, 20, 21, 22, 23, 27 would be somewhere over here. Let's draw a line, my imperfect line. And then 267 from Payne VOR. That's the VOR there. And the frequency 10.6 Payne. And we're on 267. That's 27. 267 would be somewhere over here. And we're going to draw our line out. Oh, my terribly drawn line. Yeah, a little tough, but somewhere over there, right? Now let's check. There's 227 and 267. Not bad. Right here. All right, let's try another one. We're on the 090 from Hoquiam and the 230 from Olympia VOR. First, let's identify the station. There's Hoquiam, 117.7. Make sure that's the right frequency. We've tuned it. There's the station, and we're on 090. That's this one. 090. And we're on the 230 from Olympia VOR. First, identify the station. There's the VOR, 113.4. It's actually a Vortac. And 230 is right about here. From there. And yeah, somewhere around Banas, I think. Nice. So some things to remember using a single VOR. You might actually have to, if your aircraft only has one VOR, you're going to have to, switch between the two frequencies. You want to compare your OBS setting to and from indicator with the aircraft heading. Remember that the VOR indicator doesn't tell us what heading we're flying. It looks a lot like a heading indicator, but it just tells us our relation to a specific course or radial from a station. So you've got your six-pack. It's got airspeed, attitude, altimeter, turn and slip, heading indicator, and VSI. And then your VOR needle is going to be over here. Again, it does not tell you what heading you're flying. It tells you where you are in relation to a specific course. So if we wanted to fly that 090 radial from Hoquiam, we would tune it onto the VOR and then fly the heading using our heading indicator or compass. To indicate correctly, the OBS needle must be basically set to the same heading that you're flying. So if you want to fly the 090 course, we want that selected on the VOR station or in the VOR indicator, and then we also want to fly it on our heading indicator or our compass. Your to or from indicator must correspond to the aircraft's flight path in relation to the VOR. That's saying that if you are flying, to a station, an airport here, but you've got a from indication selected, your VOR indicator is going to indicate correctly. It's going to reverse sense. So if you try to fly to a station with a from indication, it will result in reverse sensing. Alternately, if you try to fly away from a VOR with a to indication, it will also reverse sense. So you'll think you want to fly to the left, but you actually need to fly to the right. And we'll talk a bit about that a little bit more here. Essentially, if you've got Hoquiam selected and you are down here south of the station, you're trying to fly directly to Hoquiam, you need to have the 360 radial to Hoquiam selected, the 360 course. Remember that radials are always from. So this would be the 360 from, and then 360 to would be over here. We're trying to fly to the station because we need to fly a heading of 360 to fly there. If we're trying to fly away from the station on the 270 radial, then we need to fly away from the station, and it has to say to, or correction, it has to say from. So flying away from, make sure it's from. Flying to, make sure it says to. So what we do is, if we select, let's say we're flying to Hoquiam here again, we select the course that we want to fly, and in this case, we're flying the 360 course to Hoquiam, and we want to pretend that the airplane has the same heading as the OBS selected. If the needle comes off to the left, we pretend that this is essentially the line in the sand that we need to fly to. So if our airplane's over here and the course is off to our left, we want to fly to the left to intercept that course. And the way it would look, if it was offset, we've got this course selected, but we're over here. But we are off to the right, and we need to fly to the left. So the CDI needle, or the VOR indicator, just gives us an indication of where that line in the sand is. So left deviation means we are to the right, of course, and right deviation means that we are to the left, of course. And we correct by flying to the needle if we have it set correctly. If we have it set incorrectly, then the needle will tell you, hey, you need to fly to the left, but you actually need to fly to the right. So remember to set the correct setting to or from, depending on where you're going. If you don't see a to or from indication in this little box here, that means that you're in an area of ambiguity and the needle points towards the station. So if there's no to or from and the needle's off to the right, that means that the VOR station is somewhere off to your right. If the VOR needle is deflected to the left, the VOR station is somewhere off to your left. It's just an area of ambiguity. And these are some helpful images to show you what it's supposed to look like. So if we are flying over here, and in this situation, we've all four have set the 360 course in our VOR indicator. In this case, we are to the north of the station, and we have a 360 from indication because we are flying away from the station. And this needle is telling us that this course that we have selected is off to our left. So if we wanted to fly 360 from the station, we would have to fly to the left to intercept the course and then fly a HagNav 360 on that radial. If we wanted to fly this same radial, the 360 radial away from the station, and we're off to the left here, this is telling us that the course, this black line here, is off to our right, and we need to correct by flying to the right and then getting on our heading of 360. Now down here, we're trying to fly to the VOR station, and we want to fly the 360 course to the station. If we are on the needle, we'd be here, but we're not. The course is off to our left, so we're somewhere over here. We need to fly to the left to get onto this needle, and once it's centered, we know we're on this course to the VOR station. And again, over here, we're off to the left. The course is off to our right. We need to correct by flying to the right, and then once the needle is centered, once this guy is here, right in the center, we know that we are centered on this course. Again, I've got a VOR video specifically covering VORs, and I'll post it after this. Let's talk about the GPS, or Global Positioning System. This is a satellite-based system that requires 4 satellites to yield a 3-dimensional position and time solution. That is latitude, longitude, altitude, and time. Your GPS receiver, the module inside your panel, will contain really cool stuff like chart databases, maps, traffic, and weather overlays. It can also tell you or help you find VORs, DMEs, localizers, glide slopes for my IFR pilots, and can help you compute ground speed time and fuel burn. They're very, very exciting devices. For effective GPS navigation, first of all, we need to make sure that the unit we're using is approved for a planned flight. Obviously, using a cell phone GPS, it can be helpful for our situational awareness, but at the end of the day, it's not approved for VFR navigation, so you cannot say that you are a GPS-equipped aircraft. Similarly, there are GPS units that we can use in the aircraft, but that are not necessarily approved for IFR or different types of IFR flying. So you need to verify again. First of all, verify that the unit is approved for the flight. Second, we need to know our GPS unit, know your equipment, know how to input and cancel different entries. You need to know how to verify whether or not the GPS unit is up to date, because charts get updated all the time. You need to know how to program it and then review the route to make sure that it is approved by ATC. So you're not going to be busting any airspace or flying into dangerous areas. You should also integrate your navigation system with your other forms of navigation, so pilotage and VORs, dead reckoning, that stuff. Don't ever rely on one single form of navigation. That's a good way to get yourself lost. Let's talk about Receiver Autonomous Integrity Monitoring. RAIM stands for Receiver Autonomous Integrity Monitoring, and it is essentially a function of the GPS unit where it can tell you if it has enough GPS satellites to give you an accurate position. If it doesn't have RAIM, you should be suspicious of your position. Basically, you don't trust your unit if it says, hey, RAIM is not confirmed or assured. Basically, if you are flying in your aircraft here and your GPS unit does a RAIM check. It's going to check to see if it has the 4 satellites that are needed for navigation. I believe it's the 5th that is needed for RAIM, and then there's a 6th satellite to boot the wrong one and then continue offering RAIM. So 4 satellites for position, altitude, and time, and then a 5th satellite to verify that you've got RAIM, and then a 6th satellite to boot the wrong signal. So how many satellites do you need to yield a 3D position and time solution? You need 4 satellites to yield the 3D position and time solution. And if RAIM is lost mid-flight, what can be said about the accuracy of your GPS position? No assurance of accuracy is, it's not assured, basically. All right, so we hit the end here. Take 5 minutes to jot down what you can remember, and then we'll hit our quiz. Let's do it. If more than one cruising altitude is intended, which should be entered in line 15, level of a flight plan? The initial cruising altitude. Every physical process of weather is accompanied by or is a result of heat exchange. The development of thermals depends upon solar heating. ATC advises traffic 9 o'clock. This advisory is relative to your ground track. While on a VFR cross country and not in contact with ATC, what frequency would you use in the event of an emergency? 121.5. Who should not participate in the Land and Hold Short Operations Program? Student pilots. During pre-flight inspection, who is responsible for determining the aircraft as safe for flight? That's you, the PIC. VFR approaches to land at night should be accomplished the same as during daytime. How should the flight controls be held while taxiing a tricycle gear equipped airplane into a left quartering headwind area A? Left aileron up, elevator neutral. The boundary between 2 different air masses is referred to as a front. One of the most easily recognized discontinuities across a front is a change in temperature. If there is thunderstorm activity in the vicinity of an airport at which you plan to land, which hazardous atmospheric phenomenon might be expected on the landing approach? That's wind shear turbulence. During the life cycle of a thunderstorm, which stage is characterized predominantly by downdrafts? Dissipating. Which weather phenomenon signals the beginning of the mature stage of a thunderstorm? Precipitation beginning to fall. One in-flight condition necessary for structural icing to form is visible moisture. An almond or lens-shaped cloud which appears stationary but which may contain winds of 50 knots or more is referred to as a lenticular cloud. A non-frontal narrow band of active thunderstorms that often develop ahead of a cold front is known as a squall line. What is the expected fuel consumption for a 750 nautical mile flight under the following conditions? If you need more time, go ahead and pause it. 53.2 gallons. The pitot system provides impact pressure for which instrument? The airspeed indicator. Radar weather reports are of special interest to pilots because they indicate the location of precipitation along with type, intensity, and cell movement of precipitation. What service should a pilot normally expect from flight service? Actual weather information and thunderstorm activity along the route. What is absolute altitude? The vertical distance of the aircraft above the surface. When the term light and variable is used in reference to a winds aloft forecast, the coded group in wind speed is 9900 and less than 5 knots. Which in-flight advisory would contain information on severe icing not associated with thunderstorms? That'd be a SIGMET. How are significant weather prognostic charts best used by a pilot? For determining areas to avoid. Refer to illustration 8. The VOR receiver has the indication shown. What is the aircraft's position relative to the station? We are to the south. Under what conditions may objects be dropped from an aircraft? If precautions are taken to avoid injury or damage to persons or property on the surface. SIGMETs are issued as a warning of weather conditions hazardous to which aircraft? All aircraft. Where can locations for VOR test facilities be found? In the chart supplement. How many GPS satellites are required to yield a three-dimensional position and time solution? We need 4 satellites. All right, that covers it for our quiz today. Take a look at your search and rescue plan. If you have any questions, of course, feel free to shoot me questions or comments, concerns. Keep reading your handbooks, keep testing yourself, and I'll see you guys next time. Thanks again for hanging out. As always, I would love to hear any feedback you have for me, and here are the references. Thanks again. See you guys next week.